Welcome to Dev Radio. I'm here with Jeff Faddick. We are getting customers ready for our upcoming OpenAI hackathon, our second hackathon. And Jeff has put together a series of short tutorials to walk you through what the Semantic Kernel SDK does. And with that, I'll go ahead and just turn it over to you.
All right, man. Thanks a lot. Yeah. Matt, we're going to talk through Semantic Kernel, which is, think of it like an SDK for OpenAI. It's got a lot of helper things that help you be more efficient, help you really understand how to use AI in your applications. And so we're using a lot of this even within Microsoft's Copilot projects, which is really cool. So it's being battle tested all the time. So the basics of the tutorials here, I've got a series. There are currently 8 tutorials. This will continue to grow. I hope we'll get through all of them today, but we'll see. Basically, the first one here is set up your prerequisites. And so just to talk through that, you will need access to either Azure OpenAI or OpenAI directly. Either one works. Obviously, I prefer you use Azure OpenAI for all the things we add to it. But either one will work fine for these tutorials. And then you'll need these elements for your settings file, which I'll show you in just a second. You'll need the API keys, the endpoints, and then for Azure OpenAI, you can use completions or chat. Either one's fine. And then for OpenAI, you have to have the API key, the org ID, and the model that you're using. So slight differences, but the semantic kernel abstracts all that away. Once you have those set in your settings, it can then do its thing, the same code regardless, which is really cool. So you need that. And then you'll need a few extensions for Visual Studio Code to run these tutorials. There's the primary one, I would argue, is the Polyglot extension. But .NET Interactive and all that will kind of come with some of those so that you can run the tutorials the same way that I'm going to show you here. And then, like I said, there's a few definitions, vocabulary, and then it gets you into actually running some code. And the way, if you're familiar with Python, this is going to feel super intuitive. If you're a .NET guy like me, some of this is going to feel a little weird, but we're basically going to run C# code like you see here. We're going to run it in a Jupyter notebook. And so this is a IPYNB file that we're going to start with. And then it's got little segments or sections of C# code. And you'll just hit this little play button, like I'll do here. And it will run this section of C# code and then do whatever output or whatever right here in line. That's how this works. So hopefully that makes sense.
Nice.
Okay. And then I have a settings file here, which I'm not going to show you because it has all my keys in it. But I am going to show you the blank settings file. So you'll have to create a file that looks like this. So you see this JSON file. I've got it set up for Azure OpenAI, and I put both my chat and completions deployment models in here. But then you have to use your own key, your own endpoint, your own model names, whatever. This is just kind of what it'll look like. And then I have a C# class here that just reads from that file and then sets all the semantic kernel stuff up, which is not much code. You're welcome to look at this in the tutorial settings. But it just goes through and makes sure you have all these endpoints and model names in the file. And at the very end, it creates the initial kernel, which again, I'll show you more about here. But then it'll output at the end of this. So you have my settings, which is the name of this class up here. It'll load all those settings from the file. And then it'll output, hey, I was able to successfully read the following. And you can see the output down here. And if that aligns to what you were expecting it to do, then you're good to go. And that's the extent of setup. Once that's all done, you can come down here to this next thing and you can run this. And this is like the final test. So while we were successfully able to read in your settings, that's cool. We didn't actually make a call to OpenAI yet. And so if you come down here and then run this set of code, it will use your settings to make a call to your OpenAI instance. And in my case, I sent it a prompt. So finish the phrase above. And I replaced that input variable, which we'll talk more about, with how much would could. And then as AI does well, it completed how much wood could with the likeliest next set of words, which is a woodchuck chuck if a woodchuck could chuck wood. So that's actually verifying that I was able to go out to OpenAI and let it complete. So that's it. It added the popular tongue twister piece here, but not what I was looking for, but all good. So now I know I made a call through Semantic Kernel using my settings to my OpenAI instance. Pretty straightforward. So create your settings file, run those 2 sets of code, and if they all work and you get the woodchuck chuck, you did it correctly. You're off to the races. Okay. Any questions on any of that, Matt? Does that make sense?
No, just to reiterate, you have to do this one first.
You have to do this one first. Yeah. I mean, it's just, again, verifying your settings. So you really just have to do the settings file first, but these will verify that you did it correctly.
Yeah, so. Good. Then we're ready for tutorial 2 after this one?
Yeah, so we'll jump into, this is tutorial 0.
Okay, so number 1.
So now we'll get into tutorial 1. And this is going to be creating your first function. So this is, I think, the cooler stuff. So this first block, I'm just going to run again. It just runs all the same stuff we just did. It just does it in a condensed block. So you don't get a long output and calling woodchuck and all that stuff. It just does. All it does is say, go get your settings, and boom, you're done. So we run that first. It's done. Okay, so the point of this tutorial 1 is to introduce you to the idea of a semantic function. So what we've done here is say we're going to create a string called function definition, and then we're going to have this in the string. So this is just string characters. There's nothing weird about this. But what we're going to do is replace this curly brace $. That's a semantic variable. We're going to replace that here with whatever we provide semantic kernel. So essentially what we're going to do is say, all right, kernel, first thing I want you to do, this is just an instance of the semantic kernel object. I want you to go create a semantic function using this definition, just as is. And then I'm going to provide you a prompt, another string, and you're going to replace the input variable with this prompt. So this big, long, if you know thy enemy and know yourself, I think it was a Sun Tzu quote that I pulled. And then when you call the function is when it actually replaces the prompt in that function definition. So this, hey, function, invoke this with this variable. And then it's going to call OpenAI with that invoke async and then output the results of that call. So hopefully that makes sense. The call then here takes 1.2 seconds, and the content above emphasizes the importance of knowledge in order to be successful, blah, 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 blah. And so this one's really truncated now, but the idea is I went out and called this thing, and yes, I made a semantic function using my variable. So hopefully that you're following all of that. Yep. The idea is, again, you just got a function. At first, you just have this function with a variable in it, and then you can have multiple variables, which we'll show shortly. But I just have one default variable here. And so when I invoke the AI, I pass in the replacement for that, and it summarizes the content, and away I go. So if you didn't use semantic kernel, you would be making a REST API call to your OpenAI endpoint. And you could do this same kind of thing, but you would be swapping out the variable yourself, which is not hard by any means. But the other thing I've done here is I've loaded one of my functions into the kernel so that I actually could reuse this. And so the kernel can actually have many functions that you can keep loading into it. I've only loaded one so far, but basically now I'm starting to build up more kernel capabilities, and I can start to use those functions without providing new strings and making more REST API calls, because this will handle all of that for me.
Nice.
Yep. So in, whatever that is, 4 lines of code, 5 lines of code, pretty simple. And then every tutorial, I try to create exercises. I'm not going to go through all these with you guys because they're meant to be for you to do. So it's supposed to be like taking all the stuff I have above, the hands-on code you can run through, plus my explanations. And then you can try and do something similar. So in this case, go write the same kind of semantic function. You can use a lot of the same code up here. But instead of summarizing content, ask it to translate text into Tolkien Dwarvish and see what you get.
So. Is Tolkien Dwarvish just one that comes out of the box with?
No, it's a great question, but it is in the box, if you will, with the large language model. So it is out of the internet, but so is Tolkien Elvish and Klingon and a whole bunch of other languages. So pretty cool. Yeah.
Actually, Klingon was the first one I thought of. I've always wanted to use Klingon interactive tool.
Yeah, better fit for our industry. But yeah, I think I tried to make these fun and my best attempts at being clever. So hopefully you guys will get into that. But okay, so now we're on to tutorial 2. Things get a little more complicated, just a little bit. So there are different types of functions. So again, I'll run the first piece here, which is just the same setup, right? So that'll run just a second. And that's all installed. And then we get into the different types of functions. So the first one is the inline function, which you've basically already kind of seen, where I have a function definition, I give it some text, I give it a variable, I call create semantic function with that function, and then I replace that variable with whatever I need. That's called an inline function. So you've seen that work already. I'll run it again here, but you just saw that. So here I said, hey, again, here's the big long quote. Write these words in reverse order. Obviously, I have my token limit on, which is good because I don't want to waste a bunch of tokens. But it started writing the same thing. If I scroll the end, it's battle every succumb, will you, enemy, blah, blah, blah. So I just wrote it backwards. So that's what I asked it to do here instead of summarizing. So, okay, inline function, straightforward. The next one's a semantic, they call it a semantic function. Just gets a little confusing, and you'll see the word skill and plugin and stuff like that. We'll talk about that. But in here, it's slightly different. So what I did here is I defined a folder called plugins that you can see under tutorial 2. And inside of there, I've got another folder called translate plugin. And inside of there, I've got 2 files, a config.json and an skprompt.txt. So in this code, you don't see any function definition. It just says, hey, go find this directory. So go get this plugins directory and then read all of the plugins or functions, if you will, from that directory into the kernel. So you'll go to plugins and then translate plugin is the name of the plugin I want you to have in the directory, and then read that stuff in. So it's going to read in first this skprompt text, which translate the provided input variable into Pig Latin. And then the config JSON that's paired with it in the same folder is also read into the semantic kernel. And this allows you to have settings for each function. So you can predefine max tokens, the temperature, all these things that come with OpenAI. These are all things that you would have to pass to the REST call yourself. You can predefine them here. And that way, when you read it all in, each one of your functions can have its own settings. And now you're creating a library of pre-configured functions you can call.
And that gives you a lot of flexibility, just right there. Yeah.
Right. Yeah. A lot of reusability and flexibility. Absolutely. Absolutely. Yeah. So that's pretty cool. And then I'll run that one. And so here I said, put it into Pig Latin. And I passed, did you ever dance with the devil in the pale moonlight? Which is a nice quote from a pretty famous movie. And so then it translates it into Pig Latin. And I'm not an expert at Pig Latin, but I think that's right. So not
that's
one
right
of
to me.
Yeah. It's a lot of languages I don't speak, and that's one of them. And then we just, instead of calling invoke async, because we're calling a semantic function, we have to call run async. And then you tell it which function from your library you want to run, translate plugin, the Pig Latin function within the translate plugin, and then it executes that against AI with your prompt, and you get your output as you see below. So just a different way to use functions. And the last one, for now at least, is the native functions. And in native functions, it's a little more, if you're a .NET guy like me, although all of this works with Python and Java as well. But if you're a .NET guy like me and you like to get into the code, or if you're a Java guy and you like to get into the code, or girl, of course, then you can use a different pattern here where you can see I said, all right, kernel, I want you to import a skill, and I'm newing up an instance of a particular plugin. This one I call the Old English plugin. And so if I go here to that code, you can see it's just a class. I called it SK function, and I have a string input in here. And then here's the function definition with the variable that I'm passing in. So string input will get populated by the semantic kernel, and then my code will swap out that input here. And so here's where I could have it do anything, right? I could have it make more REST API calls. I could have it call databases. I could have it do file manipulation, math, whatever I needed to do. This is just .NET code. So the sky's the limit, and I don't have any limitations here like text, right? I can do literally anything I want here. And so that's the plugin that I created. So I go back to this and I run that native function. I'm passing in death cannot stop true love. All it can do is delay it for a while. Another movie quote. And I'm telling it, go create this Old English plugin, OE plugin, find the translate function, which is what you guys saw over here. So this method's called translate. And then over here, I get the output back, and it says translate the following into Old English, and it gives me the quote. And you might be thinking, well, wait a second, Jeff. I thought you wanted it to translate into Old English, not just output that. And that's actually what I want. So we'll get to the next piece here. Same code, but instead of calling Old English plugin, I'm calling Old English plugin 2. And Old English plugin 2 doesn't just output the string like this one did. This one, all it did is return this exact string. So again, it doesn't have to use AI in this function at all, right? I can make it do anything I want here. Like I said, add 2 numbers and then come back with those. And that'll become more relevant in the next couple of tutorials. But if I actually want to use AI, I can actually pass in a whole bunch of other things to my plugin, including the name of the variable I want to use. So I can have many variables. Here's input. Here's a description of that variable if I want to pass that. And then I can start to build out a new semantic kernel. Again, I just read in the same settings stuff from before. And now I'm calling create semantic function here. So it's like a function calling a function. And I'm invoking that to get different results. So if I come back to function types and now run this one, I kept back with this because now it has said, hey, rewrite death cannot stop true love. All I can do is delay it for a while in Old English. And again, another language I don't speak, Matt, but
no one does.
Right. I'm hoping that however you even say these words, that's correct. But yeah, so now you can see it did make an OpenAI call because I don't have that in my code anywhere. And so that's how a native function could also work. So those are the 3 big types: inline functions, semantic functions, and then native functions. So, and again, I have an exercise for you guys, which I won't go through. Okay, so then we'll move on here to tutorial 3. And stop me anywhere, Matt. If you
well, I'm just kind of hoping I'll wait. But I mean, I guess my question is, do the next tutorials sort of explain like how I choose which one to use for what type of problem or challenge?
Yeah, let me start with the inline though, because that one I won't explain as much. So inline is really simple, right? It's very limited because it's just a string. Like I'm passing a string to define a function with any number of variables. I can still do that. But it's at the end of the day, I'm just taking a couple of strings and combining them basically. So it's kind of limited. The next one, the semantic function, allows me to attach those configuration variables as well, right? How do I want AI to behave? I can do that with inline functions, but I have to do it in the code per call, right? Yeah. So it's just a little more work, not a lot.
Nothing reusable.
Right, right. And then the native function sort of opens the world up to you.
Yeah.
So
Yeah.
if you need just the strings, and those first two options are totally fine. It's great. There's, English is the new programming language. And so if that's where you're focused, you'll be just fine. They're also really great if you have your business developers, power users involved. Like, they can go create a lot of this stuff.
Mm-hmm.
And the dev can focus on the harder tech stuff. But native functions really are dev only, right? Like, you're in the code. So
yeah, that seems like that's where it gets exciting, where you can do some real damage.
absolutely. And so you'll see most of the rest of this, I'm
Yeah.
using native functions
Yeah.
because I have those skills and I can do that,
Yeah.
have more freedom.
I mean, just
But
calling into a SQL database opens up all kinds of fun. Yeah.
absolutely. Okay, so the next one here is about the variables, though. So it is important to understand that you can do more than one variable. They don't all have to be called input. And so the first tutorial here shows an example of that. So I'm saying, here's my function definition. I've got two variables, one called equation1 and one called equation2. I'm not using the default built-in input variable at all, because you don't have to. And then I'm doing the same create semantic function, because this is just an inline function again. I'm creating a new context, which is just a dictionary. So all this comes back with is a dictionary of key value pairs. And I called one of the keys equation1, one of the keys equation2, and I passed in these two as values to those dictionary items. And now when I call invoke async, I pass in this context, not just the string prompt, but this method is overloaded. So I pass in the sk context, and it has these two variables in it, along with the fact that I have this function, which defines this. So when I run all of that, it comes back and says, oh, well, if that's what you're giving me to solve for x and y, here are the two equations you want me to solve for. Well, then x equals 5 and y equals 2. And that one I actually can do. I can speak math, Matt. So that one actually works just fine. And it's a really good way to solve a couple of problems too, because sometimes you'll hear this, and it's true. LLMs aren't always good at math, but there are ways you can sort of make it good at math, and this is one of those. So, okay, so now I've shown you multiple variables. There is a question about, well, wait, how many other variables can I have, and how much can I vary my functions? So this next example, I define basically the whole thing as a set of variables. So you can have all kinds. It's just a dictionary again. So you can have tons of variables. I would suppose there's like a logical end to that, right? And maybe a memory end to that. But you can have a ton of these, and you can define your function with as much of this as you want, keeping in mind token limits. We always have to keep that in mind when it comes to AI. And so there is a very real limit on the amount of text that I can pass to OpenAI, at least at a time. And so here's my function definition. I'm going to replace it with 3 facts and a question. In this case, because I'm big into puzzles, I have 3 facts that I pulled from a logic puzzle. So 5 people ran a race. Al finished before Bob, but behind Cal. You get the idea. And then in what order did each finish the race? I use all of those elements to replace each of these variables in the order that I want. And now I can run that function with now a number of variables again. And then it comes back and says, oh, Cal, Al, Bob, Dia, Ellie. That's the answer, which is pretty cool.
Yeah, it was faster than I could do it. I was trying to, can I do it first? Nope.
Nice. Yeah. So it's pretty cool. I don't encourage people to cheat at their logic puzzles, but
No.
you can absolutely get some help there.
Yeah. No, I mean that's how developers think, right? So that's a really good example to understand what's going on here.
Yeah. So you could really replace all this. So maybe another example could have been, I could have had some template text. Like, I want all of my functions to always, I don't know, keep it clean and talk with authority or talk like Donald Duck or whatever. And I could say, always do that, but then replace out all of the rest of this with variables, right? And that totally works. So, Okay, so that's tutorial 3. And again, there's more exercises at the bottom. Tutorial 4. So we're going to talk a little bit more about those configuration options, which I kind of skipped over intentionally. But now that we're here, I have a bunch of definitions for all the different elements that you can swap out. So max tokens, pretty straightforward. What is the number of tokens that I want to use in this function call? Each model has a limit on its tokens that you can't exceed. There's nothing you can do about it. So for instance, the base GPT-3 model has 2,049 tokens. The GPT-4 can go all the way up to 32,000, at least currently. I heard that's going to come up again, but those are the token limits for each of those models. You can't exceed that no matter what. But in your function, using that config text or some other ways, I'll show you here in a sec, you can actually tell it, look, I don't even want you to use that. I just want you to use 200 tokens, period. And then I want you to cap at that. So keep your text response limited, right? And that way you can save on the cost and things like that, performance. Okay, so max tokens is that. Temperature and top P are very closely related, I would argue. And they have numeric ranges, 0 to 2 for temperature, 0 to 1 for top P. And they basically, what people will often call random, but they actually give you more creativity in the model. So you can have it set your temperature and top P very low, in which case you're saying, I want the LLM to be very literal. This is exactly what I asked you. I want the very likeliest response and do not deviate, right? Doesn't guarantee that it'll be repetitive, which is something we get a lot of questions on. Well, but Jeff, sometimes I get a different answer. Well, yes, because it is a large language model. That's how it works. But you can control the creativity by setting those values way down, or you can set them way high. For instance, if you're saying, hey, help me write an essay or a fictional book or develop a fictional character's background or whatever, you might want it to be more creative, right? I want you to test the limits of this. Or you're looking for creative solutions to, I heard a podcast the other day, challenge me on my business idea. Like I'm asking the OpenAI to challenge me. I don't want it to give me the same answer every time. I want it to give me new things. Like you didn't think about this, you didn't think about that. Like, so there's where you might want to play with higher temperature and top P. And then frequency and presence are also very closely related. It's basically how often I want the model to use repeat words. So if I give it a prompt where I'm using the word tree and I don't want it to come back with anything related to tree, the word tree, you got to use other words model, then you can control it with things like frequency and presence. That's pretty granular. So not sure how often people will play with that, but it's a thing. And then stop sequences are another little tricky thing, but basically you can sort of use it to define when you want the AI to take over. So I'm going to give you a bunch of stuff in a prompt, and then I'm going to have a stop sequence, and that's when I expect you to take action, or I'm breaking for a different reason. So they're a little trickier, but it is a very real and very powerful prompt engineering.
And you say with that one, play with it to get it.
Yeah. And the actual characters don't matter, like /n or # or whatever you want. Like that doesn't matter. But when you use those stop sequences, yeah, you're going to want to figure out what makes sense and am I getting a better response by using them. So, yeah. But again, I have a couple of examples here. You can see in the semantic kernel, you can definitely use those through regular code, not just in that text file. So I created a prompt template config object. I defined each of the properties of that. And then down below, it just does the same thing where I'm reading in, reading in that prompt. So sk prompt here, write a story about whatever I input. And then here's my prompt config. So it's going to define, this is how I want you to do it. These are a lot of the defaults, by the way, and I put the ranges in here. If that helps people if they want to play with that. And then pass in that config, register that semantic function. And then the story I want you to write about is an android on the run from a human. I thought that'd be kind of appropriate in AI world. um, and so I invoked that function, and I wanted there to be some creativity that when I rerun this, I don't want the same story. I want it to take some chances and go off script a bit, if you will. And so here's the story. It came out this time about an android named K4, which is not what I got last time and not what I get again if I ran it again. So cool. Any questions on that, Matt? Does that make sense?
Actually, I kind of got into it. Just summarize what we just learned.
Yeah, sure. So basically in this tutorial, what I wanted to do is introduce everybody to the different configuration options of
Got it.
OpenAI
Yep.
and how you can use semantic kernel to still use those things so that you can do
Yep.
it at a per function call rather than just at the AI level.
Yep. And for something labeled configuration, it was quite engaging.
Good. Yeah.
There's a lot in there.
Yeah, that's not always the best. Cool. Awesome. Yeah. And have fun with the Android story or swap this out.
Yeah.
So, yep. Yeah. And play with the settings, which is basically what the exercise is about. Play with the settings and see how that changes things. Right.
Yeah. Good, safe example to really get your head around temperature, for example.
Right.
Yeah.
Right. Okay. So the next one here's around chaining. So, okay, I've got all these reusable functions, Jeff. That's cool, but why? Why would I just not call each function one at a time going forward? Like, isn't that how this would kind of work? It can, for sure, but you can also chain these things, and that's where the reusability comes into real handy. So here, what I've done is I have a few different plugins, and I'm loading those, and I'm loading different kinds. So I'm using the plugins directory, and I'm saying go read in. I'll expand that. There's the puzzle plugin. So this is the semantic function style of plugin. There is a couple of native functions, so madlib plugin and chaos plugin. So they don't all have to be the same type. I've read all three of those into the kernel. And then I'm saying, here's your variables. I kept it really simple here for that and said, you have a madlib theme of rock concert. And then down below here, I'm saying, all right, now call the kernel, run async, pass in my variables, which is just the one, rock concert in this case, but then call each of these functions in this order. So I'm queuing up these functions. I'm saying, all right, call the chaos plugin to generate random numbers. Call the chaos plugin again, because that one in particular has two functions. So here's generate random numbers. And down here further is generate random words. And it's all just C# code. And then I come back in here and I say, now generate a madlib and then fill in the blanks. And these are all different function calls. So if I run that, first thing it did is say generate random numbers, and I have it hard coded in the plugin to generate 3 different random numbers. And so 3, 4, and 1. And I take those numbers in that order and I pass them to the next function where it said, all right, well, then I need 3 adjectives and 4 nouns. Oh, looks like I truncated it, but and 1 verb. I pass all of that in and then generate a madlib using this function. So the adjective crowd was verb to, and again, I truncated it. It's all there, but you can't see it. And then it said in the last one, fill in the blanks. And so now you can see the whole thing. The brave crowd was looking to the tall, smooth tree and out toward the vast expanse of the ocean. That makes no sense at all, but maybe it's fun and silly, and that's how madlibs work. So, but each one of these functions, like I said, it just is a regular, in some cases, semantic function or native function. The generate random numbers is here. And again, it just takes in, oops, let me go back up. Generate random numbers is here. And I say, okay, I've got a count, a lower bound, and an upper bound. I defaulted all these to 3, 0, and 5. So you could change them if you wanted to. That's just regular C# stuff. And then I used each one of the, I looped through each one of these to generate a certain number of random items. So how many numbers do I want? I loop through it, I get a number of randoms. And then I set all of those variables here so that down when I get to generate random words, it can say, all right, well, how many of each do I want to set? All right, so I've got these random numbers coming in. I split that comma separated list, and then I go define my function. Then I call out AI, and I generate a number of adjectives, nouns, and verbs. So in that order. So it's kind of hard coded in here, in that order. But I gave it an example here, which we'll come back to, I think, in the next tutorial, of how I wanted to do it. So that's kind of what happens is it says, all right, well then adjectives, colon, red, funny, heavy, nouns, cat, blah, 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 as an example. Obviously, those aren't the words that we got because we generated a different number of words and then had AI generate a different set of words based on that number. So anyway, that's how Chaos plugin works. Madlib works pretty much the same way. It only has one function, but it just says, hey, generate some Madlibs, swap out any number of adjectives and verbs, and give me a Madlib with those kinds of blanks, and I let AI do all of that work. So I don't code any of that. And then the SK prompt is actually pretty simple too. Use the provided list to fill in the blanks. So once I have a list of all of those random words, I take all of those and I fill out the Madlib as appropriate. So that's how it all works. But again, now the point of this one is that I'm really saying I can load in any number of functions here, and I can call them in the order I want to call them, still passing in variables, but Semantic Kernel takes care of, okay, well then I need to route you over here. I need to set these variables, pass these in, and finish out the whole thing. So
this is where I'm really starting to stretch in terms of understanding what all you can do.
Yeah.
So this is getting pretty powerful pretty fast.
Yeah, it does. It does. And the next variable or the next set of tutorials will build on this, but you're definitely getting into what I think is really more app specific stuff. Like this is how apps I think will get built. This is how co-pilots like we build at Microsoft and hopefully others will build. This is how I think you're going to start using Semantic Kernel more and more to build out that functionality.
Yeah.
So, okay. Let's jump in here to tutorial 6. Okay. All right. So that's pretty cool, Jeff. You have a set of functions, you read it in Semantic Kernel, and then you executed them in a certain order. But can we do more with that? I think we can, and you'd be right. So Action Planner. So Action Planner is another part of Semantic Kernel, just another object there. We're going to import a skill, and it's got a set. In this case, it's called the Celebrate plugin. And the Celebrate plugin has a handful of functions. So it's got generate text to celebrate given special occasion, and generate 5 gift ideas to celebrate a given special occasion. So we've got a couple of things that we can do here in this function. But at the time of running the code, maybe it's a bot or whatever you're doing, I may not know, do they want gift ideas? Or what are they going for, right? Because I've got 2 choices. I can either generate text to celebrate, or I can generate gift ideas. So maybe I don't know at the beginning what they're going to do. And I don't want to have to like parse that string or, do some kind of magic and give them different buttons to hit or whatever. Like I just want to let them ask questions, but I want to send them to the correct function. So we're going to use AI to do that as well. So Action Planner, what it does is it says, all right, create a new Action Planner object using the kernel. You've read in the skill, which has a number of functions associated with it. And then I want you to first create a plan. So I'm going to give you the prompt. I have no idea what to get my dad for Father's Day. And I want you to create the plan for that prompt, which means I'm calling out to AI. And Semantic Kernel has already set up a bunch of prompt text around this. So to help AI learn how to create a plan, given the list of functions that I have in my kernel, right? So now it takes that plan, which will output, you can see that, and then invoke that plan. So whatever you came up with, AI, I want you to go do that. So I'm going to run that. It'll take just a second. Takes a little longer, and I'll explain why here. It does have to create a plan, which means a separate call to AI. And then it comes back with that before it calls the AI again to invoke that plan. So it's making two, so twice as long as the last stuff we were doing, approximately. The plan is first. So the plan, and again, I let it get truncated because I didn't want to, but it's this JSON that comes back and it says, all right, well, here are the steps that I think you should use. So generate gift ideas is the likeliest thing here. Out of all the functions you've given me, given the prompt of, I have no idea what to get my dad for Father's Day, you probably don't want me to come back to you with celebratory text. You probably want gift ideas. Even though I didn't say gift in here anywhere, it's saying that's probably what you want, right? And then it says, all right, if that's what you want, invoke that plan, and here's a list of gift ideas. That's pretty cool if you think about it.
Yeah.
So now I don't even have to tell it what function to call. I can let Semantic Kernel and AI figure out what function to call. All I do is give it a library of functions. So that's pretty fun. Does that make sense, Matt?
It does. I guess my question is, how do you know when you can do that?
Mm-hmm. Yeah. So you kind of can do it whenever. I'm not
Yeah.
saying like if your bot is super singular in what it does, like all I do is write paragraphs of science fiction text, right? That's all I do. Well, then you probably don't need this because one of the reasons to use that bot would be to generate science fiction tests. But you can use this in any other case, I think. And you can even use that plan. So in this case, I generated the plan at the same, or right before I invoked the plan because I wanted it to be dynamic. But you could even cache that plan. So you could have a set of plans that you create, save this JSON to a file or whatever you are comfortable with, database, whatever. And then you can say, hey, here are a bunch of different plans if people ask questions like this. And so you could do that as well. I like the dynamic story better. Like, I don't know what you're going to ask. And so I'm just going to give you a bunch of things to do, and then you do whatever's appropriate.
Yeah.
So, yeah, I like this. To me, this is like my new default behavior. I have a project I'm working on where originally there was a bunch of APIs, like a whole bunch. I don't remember, like 20 something different APIs. And there was some OpenAI in some of them. And I said, well, wait a second. Let's rewrite that. We're going to have one API endpoint. If you're a GraphQL lover, you'll already love that. But we're going to have one API endpoint. We're going to call that and then take whatever prompt we get from the user. And then we're going to let Semantic Kernel's action planner figure out which API logic to go call. But it's just one endpoint, right? We take all prompts, we figure out where to direct you, and dramatically simplified the solution. So, yep, pretty cool. Pretty cool. Okay, now here's the downside of AI Planner or Action Planner. So Action Planner allows it to pick the one very best function. But the previous example I showed you guys, I called 4 functions, right? Action Planner can't do that. It'll just tell you what the one best function is. However, Sequential Planner can do that. So if you think you will need to call multiple functions, you can use Sequential Planner. It's a little more complicated. And here I used inline functions just so you could see it better what I was doing. But I've got travel destinations as a function. I've got tourist activities as a function. And I'm just saying in travel, generate one and only one travel destination. In tourist, generate a list of 3 popular tourist activities. And then, there we go. And then down here, I started creating and calling these functions. But the important part is the Sequential Planner config. I have to define a relevancy threshold. Otherwise, this won't work or give you really weird results. And so you have to tell it, well, how accurate or how relevant do the function calls have to be? Because if I don't find anything relevant, then I don't want to return you anything. Right? And if it's relevant enough, then great, I will give you a list of those. And if there are some of them that are just below that bar, I will give you the ones that are most relevant, but I won't give you the rest. which is probably what you want. So I also added a couple other functions here to generate a list of 5 cat names and a bulleted list of 3 board games, just so we have some stuff that it likely won't call. So create an instance of planner, pass in the kernel, pass in the config, and then create my plan. And so if I run that, it's going to take my prompt to generate a list of popular tourist activities for the given destination. So we have that, and then down below, it's going to come up with a new plan. And hold on a sec, where's my warm and sunny? Put it up here. Generate bullet list, book a trip. Okay, yeah, here it is. I want to book a 2-week trip to somewhere warm and sunny and get some ideas for things to do while I'm there. So I pass all that in. Some keywords it found that it thought were relevant to some of my functions were things like warm and sunny. And so it said, well, wait, if you're saying that, then you probably want the travel destinations. That's probably the function. Out of all the functions I have available to me, you probably don't want anything to do with cat names. You probably want travel destinations. And then there's a list of other ones because as you see below, it will say, all right, well, then you probably want Honolulu, Hawaii. And here are some things you could check out on Waikiki Beach, Diamond Head, Polynesian, because it used 2 functions, travel destinations and activities. Because it thought, based on the prompt you gave me of, I want to book a 2-week trip somewhere warm and sunny and get a list of things to do, then you probably want both the travel destinations and the tourist activities functions to run. You probably don't want cat names or board games. So, although I play board games when I travel, so whatever. But that's what it did, and then execute the plan and gave me those results. But now I can call multiple functions, and again, I didn't tell it what order. I didn't tell it what it needed to do. It figured out. Then you're probably going to need destinations first, and then activities. So pretty cool.
Yeah.
All right, then I'll go through one more here. We'll see how far we get. So tutorial 8 is about prompt engineering, and this is such a key, important skill. I struggle a lot of times talking to customers about this, Matt, because they'll come in oftentimes as data scientists who want to tweak the model. They want to get into the model and change and fine tune it and whatever. And that's not really how LLMs work. You can't. They are what they are. And so they often struggle with, well, what do I do to get the output that I want? That I'm used to just taking more data into the model and then changing the logic of the model. And that's not how this works. So what can I do to change the behavior of the model? And as you've seen, I think, which is why I would put this one last, it's all about what strings and stuff I pass in, the instructions that I give it. And so if I tell it to summarize, well, then it'll summarize. If I tell it Tolkien Dwarvish translation, then it'll translate to Tolkien Dwarvish. But then I started showing you examples as I was putting things in there, right? Like, wait, don't just generate me travel destinations, but comma separate them. Or don't just generate me a Mad Lib and have different formats every time because I'm going to have to read that into my UI. I want it to always be __ parenthesis value of, the Mad Lib and then close parenthesis __. I need some consistency in that. And I do all of that through prompt engineering. So setting up my prompt in a way that I can be instructing the AI that this is the completion I want you to get. Because again, all it does is say, you give me a bunch of text and I will give you the likeliest completion. So I have to give it enough text, the right kind of text, that I get the completion that I'm looking for. So that's how it works. And so there's some nice tips in here. I could go on and on in this tutorial alone, but I tried to put some of the most common ones in here, and then I'll get to some more advanced ones over time. But starting small is good. I see a lot of people put in lots of text here, and then they run into token limits, and they don't get the responses they want, because if you put in lots of text, it can sometimes confuse it. And so I may say, don't ever talk about trees. And then I'll be scratching my head like, why does it keep sending me tree stuff? Well, because if I don't give it enough another correct instruction, I've said, well, hey, look, I want you to be in or around trees, even if I don't want you to actually use the word tree. So, just like talking to a person or a toddler, maybe as a good example, I have to give it instructions, but not too many instructions to confuse it. So starting small is a key one. Sometimes telling it what not to do. And again, you have to be careful with that. But you can say, look, don't generate more than 3 ideas. I just want 3. Don't do more. I know you have more tokens, but don't do that. Only provide me with advice about my health and well-being. Only use other examples, or only use content from my SharePoint list that I gave you. Don't provide other information that you have in your own model. There's different things like that you can do to tell it what you don't want. And again, you got to be careful, but that's a great example. And then the final 2 I think I have on here, I think are really powerful, are providing examples. So you'll hear no shot, which means I don't provide an example at all. I just do what you saw above, like generate a list of cat names. Here, I'm saying generate a list of pet names, and I'm telling you, if the user says something like generate list of 5 dog names, then AI, I want you to come back with Abe, Ace, Ash, Art, and Ada separated by pipes. And then so when the user types in generate a list of 5, whatever they give me, in this case, cat now, then I'm going to swap out that, and I want you to finish. And so if I run this, I think you'll see something interesting here. Okay, I came back with cat, and it said, all right, how about Bella, Boots, Bandit, Blaze, and Bubbles? Which, something you may notice there is, hey, Jeff, you didn't say anything about always starting with bees, right? But notice the example I gave it. I always started with A's. And so what it did is it said, all right, I think what you're telling me to do here is that whenever you tell me I want a list of pet names, you want me to make sure that all of them are not only separated by pipes, but they always start with the same letter, which is not what I intended. But you got to be careful with prompt engineering. If I go in here and start to change this and I make Ace, whatever, Jerry, and Art, Sarah, and run the same thing, now they're all different, right? So prompt engineering is super important and powerful, and you got to be intentional about what you're telling it to do.
Yeah. Good example.
Yeah. And the last one works the same way. I don't have the exercise or the example here, but think of few shot as just a way to provide more examples. So it's not hard at all. It's just, instead of providing just one example, the other way I could have fixed this, providing 2 examples or 3 examples. And in this case, I could then change out all of these and say, I still want it separated by pipes, but I want different names and not always starting with A's, right? I give different examples. Or maybe with whenever they say cat, I don't want pipes. I want commas, right? And so you can change it so that multiple examples then determine your output. And that's called few shot. And so any number of examples more than one fall into that category. But that's kind of it, man. That's kind of list tutorials. Tutorial 8 coming soon. That's more about memory and embeddings. But I'll leave that for another time.
Great stuff. No, I'll have the link to the tutorials in the description. Awesome. And nice sequence. I like the way that you built to prompt engineering. Having all the other context before you get to that one is actually really helpful for me.
Good.
So I'm looking forward to spending some time with this.
Awesome. Well, thanks a ton, Matt. This is great. I hope your audience gets a ton out of it too.
Cool. Thanks so much.
All right, dude. Thanks.